Okay, firstly, you must start with the GIS map 10.3 software. So you open it. Okay, click Get Data to insert the data that acquired for the map. And then you select this one uploaded from the gadn.org, okay, for the dating the administrative area of Malaysia and had been stored in the folder. And then rename the data in order to easy to differentiate the result after all the data had been added. Okay, this layer are represent the geographic data in ArcMap and it arranged by suitable ranks for show the map for view. And then under the geoprocessing, you can click, okay, click the geoprocessing and then click in order to click the new Malaysia boundary. So now is the Malaysia boundary for the clip one is already open. So fill in the input feature the daerah.shp that you already saved in the folder, and then click feature with negri.shp for produce the new clip feature. So this one you only want to get the LOI. The clip here is meaning that the abstract input feature that overlay the clip feature. Okay, so you use this tool to cut out a piece of one feature class using one or more of features in another feature class as a cookie cutter. So this is particularly useful for creating a new feature class, also referred to as study area of interest AOI, that contain a geographic subset of the feature in another and larger feature class. So the new clip feature of the Malaysia, you can get like this for the Zeli daerah. Okay, now in order to select the Zeli area, select the report in the table window from the open attribute table and then take the feature of the Zeli. So you open the attribute table, click right at the layer, and then you specify also click on the Zeli area. So then you will save after repeat the step 5 and 6 to produce the new click feature of Jeli by change the input feature to Jeli daerah SHP and then click Jeli daerah. Okay, so now you can only get the result of the Jeli map. Okay, now very good here. So now get the data of Jeli 2040 land use. Okay, we already have the land use data that represent the land use of the Jeli. So now the map represents the land use of Jeli. Okay, then now you open the symbology in order to show the difference of the class that represent in this map. So click the symbology and click the categories by clicking right click in the layer properties and then change the value field with the class name and then click add all values. Okay, then click color rank to change the color. Okay, the result of the land use that have been differentiated based on the different color. Now you can see the different color here. So for the overall, you can see there's a lot of price in the Jeli. Okay, now you add data of the slope, and this slope data you already get from the Garmin GPS that you have been done fieldwork in that area. So you added the Garmin GPS data of slope that already transferred into the point data types in the shapefile, in the form of shapefile. Okay, so now the result of the slope data in area UMP that are mostly located at the agriculture area. So this is the most area that have the slope type. So you can add the raw data of the digital elevation model in order to see how much the degree of the slope in the area. So meaning that if the degree of the slope is very high, also it would consider the risk for the landslide. Okay, now you already put your digital elevation model RL peer. Okay, you click slope in 3D analysis that can be found in the outer box here. Okay, so in this slope, let's identify the slope, meaning the gradient or rate of maximum in Z value from each cell of the raster surface. So you insert the input and output raster and output measurement of the slope. Okay, for this one, you need to classify first what the class for the slope. Okay, you find the reference and there will be 5 classes that you want to classify. So the result is shown and change the symbology in layer properties and change the classes from 9 to 5 and click OK because 9 is too big and you want to classify into the narrow gradient based on the jelly area. So now this is the result of the slope. You can see that from 0 to 89%. So 89% is considered very high difficult of the slope. Yeah. Okay, now for the reclassify, you click the reclassify and reclassify the raster with the input raster slope measure and then click OK. So now you can get the new value of the slope area. With the result of the map of the reclass the slope, you can see that number 1, 2, 3, 4, and 5. Okay, and then convert the reclass slope into the polygon by fill in the input raster. So you reclass the slope here and then add a fill value and select the output polygon feature. So click OK. This one you want to transfer the raster into the polygon. You want to convert the raster dataset to polygon in order to overlay in the land use area. So the slope, the result of the slope in the polygon here. And then click the slope polygon in order to overlay the map by insert the input feature. So slope polygon and then click feature and then select the output feature class. So now you can get the clip of the slope polygon of the map area. Okay, so click the properties to change the symbology when you fill all the value and click OK. So this is the result of the slope jelly map. You can see that there is 5 classifications here. Okay, and then make the intersect to combine the slope directly. Okay, and then click OK. So this is the result after the intersect group data. Okay, you can find, you can see that. So click the special statistic codes in the output box and click geographically weighted regression in order you want to find the relationship between the slope and also the regression model and land use here. So insert the input feature and dependent variable, also then click OK. So here is the result of the geographically weighted regression. You can find that. Okay, and then the symbology. This is see the range of the geographically weighted regression, and you can see that where is the highest standard deviation and also low standard deviation, meaning where it's more significant on the landslide area. Okay, so here is the result of the change in properties. So now after you get the result, then you put it in the composition layer in order to show the people outside what you already get, where is the landslide area. So I put the title of the map, north area of the map, okay, legend of the map, scale bar, and also lastly make map layout, including legend, title, scale bar, and okay, here is the result of the landslide map in 3D in the form of the image. Okay, so now you can see that the result show that landscape map of the Jali district in the form of the map. Geographically weighted regression was used in this slope analysis to indicate variable place that it will cause landslide in Jali district. So it's built a local regression equation for each feature in the data set. So from this slide, this landslide map, okay, we cover that obtain of the analysis is the high chance of place for the landslide to take place. So it's important to make this analysis for the uses of the planner development in the future.